Class 10, Chapter 12, Areas Related to Circles, Module 3. Objectives. In this module, you will learn about areas of combinations of plane figures. Now the first question. Find the area of the shaded region in this figure. If PQ is equal to 24 cm, PR is equal to 7 cm and O is the center of the circle. Now listen carefully in this figure. You need to find out area of the shaded portion. RQ is the diameter. So one semicircular portion is there. Now to find out area of the shaded portion, area of the semicircle minus area of the triangle. So listen carefully, this triangle. Angle RPQ is equal to 90 degree. Why it is 90 degree? 7th class we have studied the angles in a semicircle is 90 degree. So using that property we can make angle RPQ is equal to 90 degree. So triangle RPQ is a right angle triangle. Now in this right angle triangle, RQ square is equal to PQ square plus PR square by using Pythagoras theorem. So RQ square is equal to 24 square plus 7 square. That is 576 plus 49, which is equal to 625. So RQ square is equal to 625. RQ is equal to square root of 625, which is equal to 25 centimeter. Now RQ is the diameter, which is equal to what? 25 centimeter. So what is the radius? Half of that, which is 25 by 2 centimeter. Now first, area of the right angle triangle RPQ is equal to half into base into height. So what is base here? RP into height, perpendicular height PQ. So half into 7 into 24. So 24 and 2 are cancelled, what? 12. So 7 into 12 is equal to what? 84 centimeter square. Now next, area of the semicircle. So if it is circle, area what? Pi r square. If it is semi square, what? Half of pi r square, which is equal to pi r square by 2. Now half into pi, 22 by 7 into radius what? 25 by 2 into 25 by 2. 2 and 22 are cancelled, what? 11. So 11 into 25 into 25 by 7 into remaining 2 2's are there. So 7 into 2 is 4 is equal to what? 28. Now what? When you multiply it, 6875 by 28 centimeter square. At last, area of the shaded region is equal to area of the semicircle minus area of the right angled triangle. So what is area of the semicircle? 6875 by 28 minus 84. Now cross multiply. 84 into 28 is equal to 2352. After that subtract. So what at last? 4523 by 28. We can write the answer up to that. If time is there, we can divide it, and at last what we get? 161.54 centimeter square. Now the second question. Find the area of the shaded region if radii of the two concentric circles with the center OR 7 cm and 14 cm respectively. And one more condition, what? Angle AOC is equal to 40 degree. Now what do you mean by concentric circles? Yes, two circles having the same center. Now the larger circle having the radius what? 14 cm, smaller having the radius 7 cm. Now what is angle AOC and BOD? Yes, they are two sectors. Now to find out area of the shaded portion, what? Area of the sector AOC minus area of sector BOD. Isn't it? So listen carefully. Area of the shaded region is equal to area of the sector. What is the equation? Theta by 360 into pi r square. Now since it is two sectors are there, pi and theta by 360 we can take common. Inside the bracket what? Capital R square minus small r square. Now substitute what is capital R? 14 square minus 7 square and 22 by 7 pi value. Then theta what? 40. So 40 by 360 you can cancel what? 1 by 9. So 22 by 7 into 1 by 9 into 196 minus 49. That is what? 22 by 7 into 1 by 9 into 147. Then we can cancel 147 and 7. What is 21? Now using 3 can cancel 9 and 21. So at last what? 22 into 7 by 3. Then multiply 22 into 7 what? 154 by 3 centimeter square is the area of the shaded portion. So listen carefully. Simple one question and also what? Important one is there. Okay. Now the third question. Find the area of the shaded region where a circular arc of radius 6 cm has been drawn with the vertex O of an equilateral triangle OAB of side 12 cm as center. So here one equilateral triangle and also one circular region is there. So we know all the angles of equilateral triangle is how much? 60 degree. Okay, now listen carefully. What is the equation of area of equilateral triangle? Yes, root 3 by 4 a square. So what is a? The side of the equilateral triangle is 12. So root 3 by 4 into 12 square. So 12 into 12, 1, 12 and 4 are cancelled. What? 3. Then 12 into next to 3 is what? Is equal to 36. 36 root 3 is what? Area of the equilateral triangle. Now the area of the equilateral triangle is 36 root 3. After that we need to find out area of the circular region. The angle of the equilateral triangle is 60 degree. That is angle O 60 degree. Then what is the area of the major angle of the major sector? 360 minus 60. Now you need to find out area of the major sector. Having angle what? 360 degree minus 60. So equation what? 360 minus 60 by 360 into pi r square. So what? 300 by 360 into pi value 22 by 7 into 6 square. So 6 into 6 what? 36 and 360 we can cancel 10. Then 0 0 cancel. At last 22 into 30 become 660 by 7 centimeter square. Now we need to find out area of the total shaded portion. That is area of the equilateral triangle plus area of that major sector. Just write the answer that 36 root 3 equilateral triangle plus 60 by 7 is the major sector area. Clear? Now the next one. This figure depicts a racing track. You just think the racing track. You know that. Whose left and right ends are semicircular. The distance between the two inner parallel line segments. So listen carefully, the middle portion, parallel line segments are there. So the distance between the inner parallel line segments, what? 60 meter. And they are each 106 meter long. The parallel lines are what? 106 meter long. If the track is 10 meter wide, the shaded portion, okay, that is the width of the track is what? 10 meter. All the portion 10 meter. Okay, fine. The first question, the distance around the track along its inner edge. Second one, the area of the track. Now, the first question, the distance around the track along its inner edge is what? The distance around the inner portion you need to find out. So the two parallel line segments are there. So each one having distance 106. So top and also bottom inner portion 106 plus 106. Now that two ends circular portion, its circumference of the circle is what? 2 pi r. Every semicircle what? Half of 2 pi r. But both side is there. So 2 into half of 2 pi r. So 2 and 2 are cancelled. Now 2 into pi into. Now inside portion, what is the diameter? the width between the two parallel lines, the width between the two parallel line segment is given 60. That is the diameter. So its radius what? 60 by 2. So 212 plus 2 into 2 and 2 are cancelled, remaining 1 2 only. 2 into pi value 3.14 into 60 by 2 30. So that is 212 plus multiply all that is 188.4. Now add it. When you add it, what? 400.4 meter. That is the distance around the track. Now area of the track, that is area of the shaded portion. So here we can divide that racing track into different parts. Now the parallel line segment having length 106 and width is what? The width of the shaded portion width is what? 10. So that it is one rectangle top portion and bottom also what? Rectangle portion. Its area what? Length into breadth. So what? 106 into 10 top and also 106 into 10 bottom. Next to that, both side what? A semicircular portion. So we know area of that circle what? Pi r square. So next one what? 2 into, next step, listen carefully, 1/2 is also there. So 2 into half of pi into 80 by 2 the whole square minus 60 by 2 the whole square. How is this 80? So listen carefully. Inside portion what? Then width is 60. Then top portion what? 10 width and bottom also 10 width. So the total large one circular portion radius is what? Diameter is what? 80. 60 plus 10 plus 10, 80. Now 80 by 2 is the radius. Then next one what? Inside portion 60 is there. So since the diameter is 60, radius what? 60. 60 by 2. Now 2 into 1/2 is also there. Okay. Next 106 into 10 what? 1060 plus 1060. Then 2 into half of, since it is what? Semicircle, both side is there. So 2 into the above step 1 half is there. Okay. So 2 into half into pi 22 by 7 into 80 by 2 is what? 40 square minus 60 by 2 is what? 30 square. That is 2120. Sum of that 1060 plus 1060. 2 and 2 are cancelled. Last 22 by 7 into 40 square 1600 minus 30 square 900. When you subtract what? 700. 700 and 7 cancelled, 100. So 2120 plus 2200 is equal to what? 4320. Now the next question, listen. In this figure, AB and CD are two diameters of a circle with the center O perpendicular to each other, and OD is the diameter of the smaller circle. If OA is equal to 7 cm, find the area of the shaded region. So listen, in this figure, area of the shaded region is equal to area of the two segment. So listen, that side portion BC shaded portion is there, and AC also one shaded portion. It is what? A segment. So 2 into area of the segment BC, or you can write area of the segment BC plus area of segment AC, plus what? Area of the circle with the diameter DO. Since OD is equal to OC equal to BO is equal to OA, 7 cm. That radius is given what? 7 cm. All these are what? 7 cm. Therefore, area of the segment BC is equal to area of the quadrant. So listen carefully here, angle 90 degree. Circle is divided into 4 equal parts. So area of the quadrant BOC minus area of the triangle BOC. So quadrant angle 90 degree. So 90 by 360 into pi into r, radius 7 into 7, minus half into base and height of the triangle is what? 7 itself. So 90 by 360, 1 by 4 into 22 by 7 into 7 into 7, minus 7 into 7 what? 49 by 2. Now 7 and 7 are cancelled. Then 154, 22 into 7, 154 by 4 minus 49 by 2. That is, when you cross multiply or take 4 as the LCM, 154 minus 98 by 4, which is equal to what? 56 by 4. Now, area of the circle with the diameter OD is equal to what? Pi r square. So, diameter is 7, so radius what? 7 by 2, which is 3.5. So, pi into 3.5 into 3.5 is what? 38.5 centimeter square. Here you can consider the value of pi as 3.14. Now, area of the shaded region is equal to what? That 38.5 plus 2 into what? 56 by 4 is what? 40. So 2 into 14 means what? BC having one shaded portion, AC also having one shaded portion segment. Okay. Now the next, when you add it, at last what we get? 66.5 centimeter square. Now the last question, listen carefully. The area of an equilateral triangle ABC is 17,320.5 centimeters square. With each vertex of the triangle as center, a circle is drawn with a radius equal to half the length of the side of the triangle. Find the area of the shaded region. So one condition, listen carefully. With each vertex of the triangle as center, a circle is drawn with a radius equal to half the length of the side of the triangle. A circle radius is not given. It is what? Half the length of the side of the equilateral triangle. So listen here. Value of pi is 3.14 and root 3 is equal to 1.73205. Given AB, BC and AC are equal, why? It is equilateral triangle. Now area of the equilateral triangle is what? Given 17,320.5 centimeters square. Now the equation what? Root 3 by 4 into AB square is 17,320.5. Now root 3 value what? 1.73205 into AB square by 4 is equal to what? 17,320.5. Now AB square is equal to cross multiply 17,320.5 into 4 by 1.73205. Denominator having 5 decimal place. To replace it what? We need to multiply by lakh. Then multiply, then cancel. At last 4 into 1000 is equal to 40,000. 10,000 is equal to 40,000 is there. So AB square is 40,000. AB is equal to what? Square root of 40,000, which is equal to 200 centimeter. Now the condition what? Radius of the circle is half the side of the equilateral triangle. So 200 by 2 is equal to what? 100. Now we know area of one sector, equation theta by 360 into pi r square. So if it is 3 sector what? 3 into 60 is the angle. Okay. Equilateral triangle angle is 60. 60 by 360 into pi. 3.14 into 100 into 100. Side of that radius is what? 100. Now 60 and 360 cancel. 3 and next what? 60 are cancelled. At last what? 15,700 centimeter square is there. Now area of the shaded region is equal to area of the equilateral triangle minus area of all sectors, that 3 sectors. That is 17,320.5 minus 15,700. When you subtract, at last what we get? 1,620.5 centimeters square. Clear, students? Okay, thank you.